Okay, multiplying polynomials. My puppy is sitting right here and he wants me to tell everyone hello. Anyways, so multiplying polynomials. We got into this a little bit last time, so hopefully a lot of this is review. Now remember the product rule. So if we have x to the a times x to the b, that equals x to the a plus b. Now let's look at these just distributing problems. So that's going to be x times x times 4. So that's going to be x squared plus 4x. This next one, we're going to distribute it 3 times. So that's going to be 15m to the 5th minus 5m to the 4th minus 35m cubed. Okay? Now let's look at this. So we have to distribute and then simplify the remaining expression. So this goes back to PEMDAS, so we do parentheses first. So negative 2x times 3x, negative 2x times negative 4. That's negative 6x squared plus 8x, then plus 7x. 8x plus 7x, that's 15x. Let's do C. So distribute first. So 2y times 6x is 12xy. 2y times negative 4x squared y is negative 8x squared y squared. And then plus 13x squared y squared minus 6. Well, we can combine those two middle ones. So negative 8 plus 13 is 5x squared y squared. And then normally those are flip-flops. So you want like your biggest exponents to the left and then smaller and smaller. So it would be 5x squared y squared plus 12xy minus 6. So look at this one, distribute first. You also have to distribute that negative because we can think about that as like a negative 1 right there. Whoops. Yeah, think about that as a negative. So that's going to be negative 2 times r cubed is negative 2r to the 4th. Negative 2r times negative 6r squared is 12r to the 3rd. Negative 2r plus 6 is negative 12r plus 4r cubed. Negative times 5r squared, or to the 4th is negative 5r to the 4th. Negative times 10r is negative 10r. You can combine like terms, so that's negative 7r to the 4th plus 16r cubed minus 22r. Let's do this one. We have a double parenthesis here, so you always work inside out. So we're going to start by distributing that one. So everything else falls down. So 4b bracket 2a squared minus 15ab, and then plus 10b squared from that negative 5 bracket plus 24ab squared. Now that 4b is going to distribute into there. So 4b times 2a squared is a squared b. 4b times negative 15ab is negative 60ab squared. 4b times 10b squared is 40b cubed. Now we can combine those because that 29ab squared can combine with that middle one. So negative 60 plus 29 is negative 31. So that's 8a squared b minus 32ab squared plus 40b cubed. And notice the exponents here. So I have an a and a b, right? So I started with my a's at their highest. So I went a squared a and then no a. And then the b's counted up. So it went b squared, b cubed. Okay. I've skipped some examples on this side. Feel free to do them for practice. Now, multiplying binomials. I know we did this last video. This is a lot of just review. So, we're going to distribute first. So that's going to be x squared plus 4x plus 2x plus 8, which is x squared plus 6x plus 8. We're going to use the box here. So 2x plus 1, x minus 5. So that's 2x squared, x, negative 10x, negative 5. Pull that out, you get 2x squared minus 9x minus 5. Cool? I want you to do examples G through L. You should be able to do these. Now let's multiply a binomial by a trinomial. I'm going to use distribution. So first we have x times the second parenthesis, so that's going to be x cubed plus 3x squared minus 6x. Then we have 4 times the second parenthesis, so that's going to be 4x squared plus 12x minus 24 that's going to be x cubed plus 7x squared plus 6x minus 24. Now let's do this one. I'm going to use the box on this one. I'm showing you both methods so that you can decide, okay, I like this better, or I like the way this organizes it better. It doesn't matter which one, okay? So we have k minus 5 on the left, k squared minus k minus 8 on top. So k times k squared is k cubed. K times negative k is negative k squared. K times negative 8 is negative 8k. K squared times negative 5 is negative 5k squared. Negative 5 times negative k is 5k. Negative 5 times negative 8 is 40. You can pull that out, so you get k cubed minus 6k squared minus 3k plus 40. You can do those next two examples. Now let's get into this thing. So 2x minus 3 to the 4th power. Well, remember when we had it to the 2nd power, that means that we had 2 of them, right? Well, to the 4th power means we have 4 of them. So let's just start doing this. So we're going to start with those two right there on the left, or on the right, I meant. So I'm going to use the box. 2x minus 3, 2x minus 3. Well, that's 4x squared minus 6x plus 9. So that's 4x squared minus 12x plus 9. Now that can replace those two parentheses right there. So I have 2x minus 3, 2x minus 3, 4x squared minus 12x plus 9. Now those 2x minus 3's can also become 4x squared minus 12x plus 9. Now we have 4x squared minus 12x plus 9 times 4x squared minus 12x plus 9. So we can draw a 3 by 3 box. So that's going to be 16x to the 4th minus 48x cubed, 36x squared minus 48x cubed, 144x squared, negative 108x, 36x squared, negative 108x, 81. If you don't know those numbers off the top of your head, it's okay. We have calculators for a reason, okay? Now we can pull that out, so you get 16x squared, negative 96x cubed, 216x squared, or that was x to the 4th, sorry. X to the 4th, x cubed, 216x squared, minus 216x plus 81. Kind of ugly, it's alright though. Let's do this one. So 3x minus 4 to the 3rd power. So that means we have 3 of them. So let's do those two first. So 3x minus 4, 3x minus 4. So that's going to be 9x squared minus 12x plus 16. So that's 9x squared minus 24x plus 16. That can replace those two. Now we have a 2 by 3 box. Oh, and I already filled it out. So 9x squared times 3x is 27x cubed. Negative 24x times 3x is negative 72x squared. 16 times 3x is 48x. 9x squared times negative 4 is negative 36x squared. Negative 24x times negative 4 is 96x. And 16 times negative 4 is negative 64. Pull it all out and you get 27x cubed minus 108x squared plus 144x minus 64. Cool? Alright. Okay, let's get into something that's a little bit different. Most of that has kind of been reviewed. You've done it last year, hopefully. Now let's talk about closure. So closure is when an operation on members of a domain always make a member of the same domain. Or members of, I don't know if domain's the right word. So set of a set are of the same set. Domain, set, I don't care which one you put. Okay? Now, let's do an example with integers. So on your paper it's polynomials. Let's do it with integers. So we have a plus b equals c. And we want a, b, and c to be integers. Okay? An integer is a positive or negative whole number including 0. So negative 1, or negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, to infinity, and down to infinity. Okay, sorry, that's my dog. You can probably hear them fighting. Now, so we have the integers, and we're going to just draw this in a circle. So say we have an integer a, and we have an integer b, and we want to see if it equals, if C is also an integer. Okay, so let's do this. Let's plug some numbers in. So let's say A equals 1, B equals 2. Well, 1 plus 2 is 3. Is 3 an integer? Yes, it is. Let's do another example. So we have negative 4 plus 3. So we're saying A is negative 4, B is 3. That equals negative 1. Is negative 1 an integer? Yes. So are the integers closed under addition? What that's saying is if you add two integers, will you get another integer? The answer is yes. Let's check for subtraction. So are the integers closed under subtraction? So if you subtract two integers, will you get an integer? Well, this is very similar to the addition one. So if you had like 9 minus 4, that would get you 5. Negative 3 minus 12, that would get you negative 15. You could do that with any integer. Get as big as you want, as small as you want. You'll always get an integer. So are they closed under subtraction? Yes. Are they closed under multiplication? So let's test it out. So 3 times 4, you get 12. Yeah. Negative 3 times negative 2, you get 6. Yeah. If you did negative 4 times 9, you get negative 36. Still an integer. So yes, those are closed under multiplication. Now are the integers closed under division? So say we have 3 divided by 4. Well, that equals 3/4. 3/4 is not a whole number. So no, they are not closed under division. Okay, so that's a counterexample to show when they are not closed. Sorry. So let's think about polynomials now. What classifies a polynomial? So polynomials can have constants, and they could be fractions. They're any number like can be a fraction. So any of the terms, not the exponents, but just the constants can be fractions or whole numbers. Variables x, y, z, r, q, p, a fish, whatever. Exponents, they can only be 0, 1, 2, 3, 4, 5, 6, 7, 8. So they can only be positive whole numbers or 0. Okay? And they can be combined with addition, subtraction, multiplication, and division, except not division by a variable. So say that you have, this basically means no fraction in exponents and no negative exponents and no variables in the bottom of a fraction. Okay, that's very, very important. And I want you to try to determine if polynomials are closed under addition, subtraction, multiplication, and division. Okay, we will talk about this tomorrow in class. Okay, remember to take the quiz. Remember, you guys are super, super awesome. I'm very excited that you're in my class. Okay.